For today's lesson, we will be discussing about differentiation of inverse trigonometric functions. So let's start with the rules for the derivative of inverse trigonometric functions. So we have six inverse of trigonometric functions. So we have the arc sine, arc cosine, arc tangent, arc cosecant, arc secant, and arc cotangent. So these are the formulas or the rules that we have to follow if we want to get the derivatives of inverse of trigonometric functions. So you might be wondering, wow, there's a lot of formulas here, and if you will just look closely at this set of formulas that we have, you will notice that there are always two of the functions that have the same formula but different signs. So let's try to group them. These two right here, arc sine and arc cosine, so they have the same formula. We have 1 over square root of 1 minus x squared, but the other one is negative. So the negative here is the arc cosine. So if you can still remember with our discussion in trigonometric functions or the derivatives of trigonometric functions, those functions that starts with c, or the cosine, cosecant, the cotangent, those are the functions with negative derivatives. So same as with the inverse of trigonometric functions. Another one is this two right here, arc tangent and arc cotangent. Again, they have the same formula, which is 1 over 1 plus x squared. And then the cotangent is just negative. And then lastly, we have these two, arc cosecant and arc secant. Again, they have the same formula, 1 over absolute value of x times the square root of x squared minus 1. But cosecant or arc cosecant is negative. So again, these are the formulas that we have to follow if we have x as the function of our inverse trigonometric functions. And as what we know, it's not always arc sine of x, arc cosine of x, arc tangent of x. It can be arc sine of 3x, arc cosine of 5x, arc cosine of 5x over 5 or 5x over 2. So if the case is like that, then we have to apply the chain rule. But we can actually combine the concept of chain rule with these formulas right here. So that's why we come up with this formula. So here we have these formulas here. These are the formulas for the derivative of inverse trigonometric functions with chain rule. So this is the one that we will use if we see that our inverse function still has a function within it. For example, arc sine of x squared, arc secant of x plus 5. So something like that. So instead of using the chain rule separately, we just combine it with the formula. So it's still the same as with the first one that I gave you. The only difference is that we use u instead of x. And then all of the numerator, we change it with du. Now what is du? Du means we have to get the derivative of u. So u here is our inner function. So as what you remember with our chain rule. So we still have arc sine and arc cosine with the same formula, wherein arc cosine is just negative. So it's now du over square root of 1 minus u squared. Arc tan and arc cotangent are still the same, but again we have du over 1 plus u squared. And then this two right here as well. Okay, so all of the variable x from the previous formula, we just replace it with u, which is our inner function. So you have to identify it in your inverse trigonometric function. And then all the numerator will become du, which means you have to get the derivative of u. So let's try it with this example. Let's say we want to get the derivative of f of x equals tangent or inverse tangent or arc tangent of 3x. So sometimes the inverse of trigonometric functions is written in words, as what you saw in the formulas, wherein we use the word arc, arc sine, arc tangent, or it can be like this, wherein we have the negative 1 for the function. So here we have, again, arc tan of 3x. So here we can set our 3x as our u, or our inner function, because this whole tangent or inverse tangent is one term, and within this term there is a function inside, which is this one. the 3x. So we set that as our u. Now, since this is inverse of tangent, or the arc tangent, so we will be using the formula du over 1 plus u squared. So let's just apply it here. So f prime of x is equal to du. That means we have to get the derivative of u, which is 3x, over, and then we have 1 plus u squared. So u is 3x, and then we square it. And then we just have to simplify this. So the derivative of 3x is 3 all over 1 plus, and then we have to square 3x, and that will give us 9x squared. And then that's it. That's now the derivative of our function arctangent of 3x. Second example, g of x equals arcsecant of x over 2. So for this example, again, we have the secant function. Again, there's only one term. There's no other term added, subtracted, multiplied, or divided with our secant of function. So we only have one term here, but that secant function still has a function inside, which is x over 2. So that means we will set that as our u, x over 2. And then, let's now apply here the derivative for arcsecant, which is du over absolute value of u times the square root of u squared minus 1. So let's apply it here. So g prime of x is equal to, and then let's get the derivative of u, which is x over 2, over, then we have absolute value of u, absolute value of x over 2, times the square root of u squared, so that is x over 2 squared minus 1. And then all you have to do is to simplify this. So derivative of x over 2. Now the derivative of x over 2 is just 1/2. Now how did we get 1/2? X over 2 can be written as 1/2 x. Okay? Wherein 1/2 now is the numerical coefficient of x. And if we encounter something like this, and then we have to get a derivative, you just have to, again, get the numerical coefficient. So that's why the derivative of x over 2 is 1/2. And then, let's solve the denominator. So we have here the absolute value of x over 2. Now, for this one, square root of. So we have to square this. So that is x squared over 4, then minus 1. Now for the numerator, let's just let it like that, 1/2. Let's focus first on the denominator, and then let's simplify this. So we have 1/2 over. Now, what we will do here is we have to combine our denominator. I mean these terms inside the radical symbol. So since, as you can see here, there are two terms, they are being subtracted, so we cannot really simplify this. So in order for us to simplify, we have to write them as one fraction only, wherein their denominator is 4, because that's what we have here. So what you can do is you can just get the LCD, or you write 4, you write the x squared, just have to multiply 4 with 1, and then that's it. You now have the new numerator. So minus 4. Again, what is the reason why we have to write them as 1? Because if we will just leave it as like that, we cannot simplify. Remember, with the rules of our radicals, you cannot get the square root of x squared over 4 and then subtract it to the square root of 1. So that's a no-no. We cannot do that. We can only separate the terms inside our radical symbol if they are separated by multiplication or division. But if they are connected by addition and subtraction, so we cannot get the square root of the terms separately. So that's the reason why we have to combine them as 1. Now, after that, you will see that we have now square root of x squared minus 4 all over 4. So we now have two terms, the x squared minus 4 and then the 4, and they are divided by one another. So what we can do here is we can now get the square root of the numerator and the square root of our denominator. So what we will do is, so 1/2 over, and then we have the x over 2 Now get the square root of the numerator, so it should be multiplied, and that is just simply x squared minus 4. And then you get the square root of the denominator, which is 4, and that is 2. Okay, so that now is our new denominator. Now from here, you have to simplify it further. Since, as you can see, there's a fraction within a fraction, so we have to cancel out the denominators. So we don't want the denominators here. So what we will do is we have to multiply the whole fraction, the numerator and the denominator, by a certain number so that we can cancel this out. Now, we will be using 4 over 4. Now, why do we have to use 4 over 4? Because if I multiply 4 to 1/2, 2 will be cancelled. So it will be just equal to 2. And if I multiply 4 to our denominator, so I have 2 here, I also have 2 here. So that means it's 4. So I can cancel out. Okay? So what we will do here is, let's multiply 4 times 1/2 over. And then this one, so you write 4 times, then we have the absolute value of x over 2. So we can just write it as like this. Times, and then x squared minus 4 all over 2. So we can cancel this, we can cancel this, so we will end up with 2 over the absolute value of x times the square root of x squared minus 4. And then that's it. That is now our final answer. So that is now the derivative of our arc secant of x over 2. And for our last example, let's say we have here arcsine of 3x over x plus 3. So in this case, the u that we will be using is the 3x over x plus 3. So we have here arcsine. So let's now get the derivative of that. So the formula, du over square root of 1 minus u squared. So that's the formula that we're going to use. So first, get the derivative of u. So we will place that in our numerator. And then, all over the square root of 1 minus the u squared. So u squared. Okay? Next. Now, we have to get the derivative of our numerator, or the u. And as you can see, u is 3x over x plus 3. That means we have to apply the quotient rule. So this is our high, this is the low. So let's apply now the quotient rule in our numerator. So let's now write low d high minus high d low all over low squared. So that is for the numerator. And then we still have to write all over the denominator, this one, which is the square root of 1 minus, then we have the 3x over x plus 3 squared. Okay, again, we applied quotient rule in the numerator since we have 2, because the numerator and denominator are separated by division. And then next, let's just solve for the derivative in the numerator. So let's write here, we have the x plus 3 as is, and then 3x, its derivative is 3, minus, then we have 3x, and then the derivative of x plus 3 is 1. All over, and then we have the x plus 3 squared. Okay? All over square root of 1 minus 3x x plus 3 squared. We will just focus first at the numerator. So let's combine this one or simplify this even more. So we have here x plus 3 times 3, so that is 3x plus 9 minus 3x all over x plus 3 squared all over the denominator, which is square root of 1 minus 3x over x plus 3 squared. So again, we are just simplifying first the numerator, and we applied the quotient rule there. Okay, now after that, we will just simplify this. As you can see, 3x and 3x, we can cancel this 2, and we will be left with 9 as our numerator. So let's write it here. So we have 9 over the denominator, x plus 3 squared. So this one right here, all over, and then I will just copy this one, all over square root of 1 minus 3x over x plus 3 squared. Okay, so now here we're done simplifying the numerator, so let's just leave it as like that. Let's now go with our denominator. So what are we going to do? So we will just simplify this. So since 3x over x plus 3 is raised to 2, so let's distribute the power. So we have 9 over x plus 3 squared all over, and then we have square root of 1 minus, so this will become 9x squared, and when for our denominator, let's just write it as x plus 3 squared. So we will not expand it first because it will be easier for us to solve if we will just leave it as is. So here we have two terms in our denominator, and they are separated by subtraction. So that means we cannot get the square root of 1. We also cannot get the square root of 9x squared over x plus 3 squared. So in order for us to simplify this, we have to combine the two and write them as one fraction. So like what we did in the previous example, so we will do it again here. Square root of. So again, you just have to write them as one fraction, and then we will use this as our denominator. So that's x plus 3 squared. So just multiply to 1. So you have x plus 3 squared minus 9x squared. Okay? And then from here, what you will do is you will expand x plus 3 squared in the numerator so that we can simplify it with 9x squared. So just copy all over, and then let's expand this one, the x plus 3 squared. So if you do that, it will become x squared plus 6x plus 9, and then minus 9x squared all over, and then we still have the x plus 3 squared in the denominator. Let's further simplify the numerator in the radicand. So we have x plus 3 here all over. So we can combine similar terms, x squared minus 9x squared. So that's negative 8x squared. And then plus 6x plus 9. And then our denominator will be x plus 3 squared. And then from here, since we already simplified the numerator of our radicand, and then they are now in one fraction with x plus 3 squared, we can now get the square root of the numerator and the square root of our denominator. Now, for our numerator, we will just leave it as like that because again, we cannot get the square root of each term. But for the denominator, since it's x plus 3 squared, so we can get the square root of that. So what we will have here is the square root of negative 8x squared plus 6x plus 9 all over the square root of x plus 3 squared, which is x plus 3. So this is now what we have. Now, we're done simplifying both the numerator and the denominator, and as you can see, they still have a denominator within them. So we have to cancel that one out so that we can simplify this one. So to do that, we have to multiply our numerator and denominator by a specific term, and that is x plus 3 squared. Now, why not just x plus 3? Why do we have to multiply it by x plus 3 squared? Because if we will just multiply it by x plus 3, if we multiply it on the numerator, we will still have a denominator since the denominator here is squared. So that's why we will consider the highest denominator that we have, and that is x plus 3 squared. So you multiply it both. So let's write x plus 3 squared, and then I multiply it with 9 over x plus 3 squared. Also, the denominator, x plus 3 squared, multiply it with the denominator, negative 8x squared plus 6x plus 9, all over x plus 3. And then this will be cancelled. This one will be cancelled too, but we will be left with 1x plus 3 here. So therefore, our final answer will be 9 over, then the remaining x plus 3 times the square root of negative 8x squared plus 6x plus 9. And then that's it. That is now our final answer. So we're able to get now the derivative of our inverse of trigonometric function. So that's it for today. I hope you learned something about how to identify the derivatives of trigonometric functions, and see you next time.